Joseph Fourier. Joseph Fourier. Jean-Baptiste Joseph Fourier was a French mathematician and physicist born in Auxerre and best known for initiating the investigation of Fourier series, which eventually developed into Fourier analysis and harmonic analysis, and their applications to problems of heat transfer and vibrations. The Fourier transform and Fourier's law of conduction are also named in his honor. Fourier is also generally credited with the discovery of the greenhouse effect. Biography. Fourier was born at Auxerre, the son of a tailor. He was orphaned at the age of 9. Fourier was recommended to the Bishop of Auxerre, and through this introduction, he was educated by the Benedictine order of the convent of St. Mark. The commissions in the scientific corps of the army were reserved for those of good birth, and being thus ineligible, he accepted a military lectureship on mathematics. He took a prominent part in his own district in promoting the French Revolution, serving on the local revolutionary committee. He was imprisoned briefly during the Terror, but in 1795 was appointed to the École Normale and subsequently succeeded Joseph Louis Lagrange at the École Polytechnique. Fourier accompanied Napoleon Bonaparte on his Egyptian expedition in 1798 as scientific advisor and was appointed secretary of the Institut d'Egypte. Cut off from France by the British fleet, he organized the workshops on which the French army had to rely for their munitions of war. He also contributed several mathematical papers to the Egyptian Institute, which Napoleon founded at Cairo, with the view of weakening British influence in the East. After the British victories and the capitulation of the French under General Menou in 1801, Fourier returned to France. In 1801, Napoleon appointed Fourier prefect of the Department of Isère in Grenoble, where he oversaw road construction. Other projects. However, Fourier had previously returned home from the Napoleon expedition to Egypt to resume his academic post as a professor at École Polytechnique when Napoleon decided otherwise in his remark. Hence, being faithful to Napoleon, he took the office of prefect. It was while at Grenoble that he began to experiment on the propagation of heat. He presented his paper on the propagation of heat in solid bodies to the Paris Institute on 21 December 1807. He also contributed to the monumental description de l'Egypte. In 1822, Fourier succeeded Jean-Baptiste Joseph D'Alembert as permanent secretary of the French Academy of Sciences. In 1830, he was elected a foreign member of the Royal Swedish Academy of Sciences. Fourier never married. In 1830, his diminished health began to take its toll. Shortly after this event, he died in his bed on 16 May 1830. Fourier was buried in the Père Lachaise cemetery in Paris, a tomb decorated with an Egyptian motif to reflect his position as secretary of the Cairo Institute and his collation of description de l'Egypte. His name is one of the 72 names inscribed on the Eiffel Tower. A bronze statue was erected in Auxerre in 1849, but it was melted down for armaments during World War II. Joseph Fourier University in Grenoble is named after him. Real roots of polynomials. Fourier left an unfinished work on determining and locating real roots of polynomials, which was edited by Claude Louis Navier and published in 1831. This work contains much original matter, in particular, Fourier's theorem on polynomial real roots, published in 1820. Fourier's theorem on real roots of polynomials states that a polynomial with real coefficients has a real root between any two consecutive zeros of its derivative. François Boudin, in 1807 and 1811, had published independently his theorem, which is very close to Fourier's theorem. Fourier's proof is the one that was usually given, during 19th century, in textbooks only. Theory of equations. A complete solution of the problem was given in 1829 by Jacques-Charles François Sturm. At Rosenbaum and E. L. Davis. Fourier's theorem. At Rosenbaum and E. L. Davis. Discovery of the greenhouse effect. In the 1820s, Fourier calculated that an object the size of the Earth and at its distance from the Sun should be considerably colder than the planet actually is if warmed by only the effects of incoming solar radiation. He examined various possible sources of the additional observed heat in articles published in 1824 and 1827. However, in the end, because of the large 33-degree difference between his calculations and observations, Fourier mistakenly believed that there is a significant contribution of radiation from interstellar space. Still, Fourier's consideration of the possibility that the Earth's atmosphere might act as an insulator of some kind is widely recognized as the first proposal of what is now known as the greenhouse effect, although Fourier never called it that. In his articles, Fourier referred to an experiment by de Saussure, who lined a vase with blackened cork. Into the cork he inserted several panes of transparent glass separated by intervals of air. Midday sunlight was allowed to enter at the top of the vase through the glass panes. The temperature became more elevated in the more interior compartments of this device. Fourier concluded that gases in the atmosphere could form a stable barrier like the glass pane. This conclusion may have contributed to the later use of the metaphor of the greenhouse effect to refer to the processes that determine atmospheric temperatures. Fourier noted that the actual mechanisms that determine the temperatures of the atmosphere included convection, which was not present in de Saussure's experimental device.